Welcome to AT Math Academy. Topic for today is 3 by 3 matrix determinant. So let's start by taking an example of a 3 by 3 matrix, which is 5, 6, 12, 4, 9, 8, 2, 1, 7. So this is my 3 by 3 matrix, and for finding the determinant of this 3 by 3 matrix, we should be finding the cofactor for the matrix. In my earlier videos, I have shown you how to find out the cofactor. So let's first write down the formula for determinant. So we should be taking, I can take any row or any column here. So I'm going to take my first row of this matrix. So the elements are 5, 6 and 12. So I'm taking my first element, and it's needed to be multiplied with cofactor of 5. And my second element here is 6. So I need to add plus 6 and cofactor of 6. Cofactor of 6. And my third element is 12 and cofactor of 12. So this is the formula for finding the determinant. And now let's start by finding the cofactor of each elements. So cofactor of Aij element with first any I is the row and j is a column, and this is the element. So cofactor of any element can be written as -1 to the power its row plus column I plus j multiplied with minor of that matrix. And in my earlier videos, I have shown you how to find out the minor of the matrix, which is minor can be found out by eliminating that particular row and column and finding the determinant of the remaining matrix. So let me explain it. Let's find out the cofactor of first element, which is 5. It can be written as, so since 5 is my first element in the matrix, and my I and j values will be my first row and first column. So it will be -1 to the power 1 plus 1, because I is the row and j is the column, and 5 is in first row and first column. So I plus j becomes 1 plus 1, and minor is the matrix that is formed by eliminating the first row and first column. So let me rewrite the matrix for you here, which is 5, 6, 12, 4, 9, 8, 2, 1, 7. So for finding the minor of the 5, which is first row and first column, I'm eliminating that with the boxes here. My remaining matrix would be in the brackets. So I need to find out my minor would be determinant of 9, 8, 1 and 7. So this is how you find out the cofactor of 5. Okay, and let's write the equation for cofactor of next element, which is 6. And 6 here in the matrix is first row and second element. So first row and second element, which is -1 to the power I is 1 and j is the second column. So it is 2. And the determinant would be, minor would be the determinant of the eliminated row and column of that matrix. So I'm again rewriting for you to show the remaining matrix that is after eliminating first row and second column. So we are eliminating the ones on the boxes. The remaining matrix would be 4, 8, 2 and 7. So the determinant would be 4, 8, 2 and 7. That gives the cofactor of 6. So next comes the cofactor of 12. 12 is my first row, third column, first row and third column. So I'm writing it as -1 to the power 1 plus 3 and the determinant would be eliminating my column element with row and the column. So I'm finding the cofactor for 12, so I need to eliminate the row of 12 and the column of 12 and find out the determinant of remaining matrix, which is 4 9 2 1. Okay, so let's solve it. Minus 1 to the power 1 plus 1 is 1, and determinant of this is A B C D. Standard matrix determinant formula is AD minus BC. Multiply the diagonal elements and subtract the product of those. So 9 times 7 minus 8 times 1. And here it is minus 1 to the power 1 plus 2 is nothing but 3. And 4 times 7 minus 8 times 2. Here it is minus 1 to the power 1 plus 3, which is 4, which is minus 1 to the power 4 times 4 times 1 minus 9 times 2, which is 9 times 7 is 56 minus 8. So this 9 times 7 is 63 minus 8, which is 55. And here this is minus 1 and it is multiplied with 28 minus 16. 28 minus 16 is nothing but 12, and it is multiplied with minus 1, so this becomes minus 12. And here 4 minus 18 is nothing but minus 14, and it is multiplied with 1. Minus 1 to the power 4 is nothing but 1, and here 4 minus 18, which is minus 14. So these are the cofactors here. Now for finding the determinant, we should be calculating the determinant. Here I took my first row, so determinant would be my first row element multiplied with its cofactor of 5. Okay, and my second element is positive 6, so I'm going to add that with cofactor of 6. And my next element is 12 with cofactor of 12. So this becomes 5, and cofactor of 5 here is 55, and cofactor of 6 is minus 12 for us. Cofactor of 12 is minus 14. So this becomes 55 times 5, which is 55 times 5. 5 times 5 is 25, and 27. 275, and minus 6 times 12 is nothing but 72, and 12 times 14. Let's do it. 12 times 14. So for doing 2 by 2 multiplication, we need to take each digit of the second element and multiply with all the digits of the first element. So I'm taking 4 and multiplying with 2, I get 8, and 4 multiplied with 1, I get 4, and I'm adding, and I'm multiplying my next element 1 with 2 and 1 with 1. I'm getting it as 168, so I'm writing it down here. So when you simplify everything, 275 minus 72 minus 168, everything, finally you'll be getting the determinant as 35. So this is how you solve the determinant of a 3 by 3 matrix, and this is a total glimpse of the problem. So for solving the determinant, we are going to take any row or any column and multiply all the elements with the cofactors and add the resultant. So 5 multiplied with cofactor of 5, and 6 multiplied with cofactor of 6, and 12 multiplied with cofactor of 12. That is a determinant. And for finding the cofactor, I'm using the formula minus 1 to the power I plus j multiplied with its minor mij. Minor can be found out by eliminating that particular row and column. So for finding 5, I'm eliminating my first row and first column, and I took the minor as 9817, and I found out the determinant for that. And minus 1 to the power I plus j is, this is first row first element, so 1 and 1 for I and j. So for 6, it is first row second column, so it is 1 and 2. So this is how you solve it. Hope you all like my video, and please subscribe to ET Math Academy. And thank you for taking time to watch the video. Enjoy doing math at 80. Thank you.